In this session, I am going to discuss initial value and final value theorems in Laplace transform. So we start the initial value theorem first, then we'll go for final value theorem. Initial value theorem. So initial value theorem. So initial value. So initial value means what actually it means is initial value represents x of t value at t is equal to 0. Similarly, final value represents x of t at t is equal to infinite. Final value represents x of t at t is equal to infinity. And remember that these initial value and final value theorems, initial value and final value theorems applicable to or valid theorems valid for unilateral Laplace transforms. Unilateral Laplace transform. Meaning is that that is valid from the limits of integral 0 to infinity. So with this basic information, so we'll move to the initial value theorem. So initial value theorem states that if x of t is a continuous time signal, then its Laplace transform is x of s. Then limit t tends to 0 x of t. So x of t value at t is equal to 0, then its Laplace transform becomes limit s tends to infinity s into x of s. Now we'll try to understand the proof of this statement. So if signal is dy dt of x of t, then how we write the Laplace transform? So Laplace transform of d by dt x of t. Suppose signal is this, then Laplace transform of this signal will be 0 to infinity d by dt of x of t e power minus st dt. Let's say this is equation 1. In the same one, using differentiation equation, using differentiation property of Laplace transform, differentiation property. So we can write Laplace transform of d by dt x of t is integral 0 to infinity it is directly we can write s into x of s minus x of 0. So this is equation 2. Now observe the equation 1 and 2. The left half portion is same, then the right side expression should be equal. So we write from equation 1 and 2, from equation 1 and 2. So we write integration of 0 to infinity, the right side portion of first equation, d by dt x of t e power minus st dt equals to right side portion of second expression, second equation, s into x of s minus x of 0. Okay. So no, we need the expression at infinity value, s tends to infinity. So we apply limit s tends to infinity on both sides. So now left half side it becomes limit s tends to 0, sorry, s tends to infinity, limit s tends to infinity, integral over 0 to infinity d by dt of x of t e power minus st dt equals to limit s tends to infinity s into x of s minus x of 0. So now observe the left half portion. So we apply the limit inside to this. So 0 to infinity d by dt x of t e power, so minus s into t. So s is now infinity. So it becomes e power minus infinity into t is infinity dt equals to limit s tends to infinity s into x of s minus x of 0. So now observe this e power minus infinity. So this value is 0. E power minus infinity value is 0. So this entire equation becomes 0 left half side. So 0 equals to limit s tends to infinity. So s into x of s, and this minus x of 0 is independent of s, right? So we can write it outside x of 0. So now x of 0 shift to the another side. So we will get x of 0 is equal to this minus x of 0 shifts here, it becomes plus x of 0 is equal to limit s tends to infinity s into x of s. So x of 0 is x of 0 is the value of x of t at t is equal to 0, right? So we can write it as limit t tends to 0 x of t equals to limit s tends to infinity s into x of s. So this is the proof for the initial value theorem in Laplace domain. Similarly, the final value theorem of Laplace transform says that it represents the value of x of t at t is equal to infinite. Final value theorem which says that if x of t is the signal, then the Laplace transform of this one is x of s. Then the final value of this we can write it as limit t tends to infinity x of t. Then its Laplace transform becomes limit s tends to 0 s into x of s. Now try to understand the proof of this particular statement. So we start the same Laplace transform of d by dt of x of t. How we write in general is equals to integral over 0 to infinity d by dt of x of t is my signal now. Then e power minus st dt. So let's say this is equation 1 in final value case. From differentiation property of Laplace transform. And differentiation property of Laplace transform. Differentiation property is already explained in previous lecture. So if you want to see the details about this, just please refer the video on differentiation property in Laplace domain. So this is Laplace transform of d by dt of x of t is integral over, sorry. So this is s into x of s minus x of 0. So for convenience, let's say this is equation 2. Now from equation 1 and 2, from equation 1 and 2, we write the right side parts are equal. So integral 0 to infinity d by dt of x of t e power minus st dt equals to s into x of s minus x of 0. Now we need the value at s tends to 0, right? So we apply the limits on both sides. Just apply limits s tends to 0 on both sides. So now this becomes limit s tends to 0 integral over 0 to infinity d by dt of x of t e power minus st dt is limit s tends to 0 s into x of s minus x of 0. Now substitute s is 0 in this equation, 0 to infinity d by dt x of t. So e power minus s is 0 now, dt equals to limit s tends to 0 s into x of s minus x of 0. So now e power minus 0 value, we know that this value is 1. So then it becomes 1 into the expression. So this is integral 0 to infinity d by dt x of t dt equals to the right half expression we are not disturbing, so we are carrying out as it is, s into x of s minus x of 0. So that equals to, now observe this, after performing integration and differentiation to the x of t, so we get here x of t for the limits 0 to infinity equals to limit s tends to 0 s into x of s minus x of 0. So here we can write this x of 0 separately because x of 0 is independent of s. So we can write separately. So now apply the limits in the left half portion. So we'll get x of infinity minus lower limit x of 0 equals to limit s tends to 0 s into x of s minus x of 0. Now both sides x of minus x of 0 become cancelled and the expression remains is x of infinity equals to limit s tends to 0 s into x of s. So x of infinity means it is the value of x of t at t tends to infinity. So same thing, we can write it as r limit t tends to infinity x of t equals to limit s tends to 0 s into x of s. So now observe this, the value of x of t at infinity is equivalent to the value of x of s at s is equal to 0. So this is the statement of final value theorem in Laplace domain.